Hi there. So we want to do a little bit of review of the Java programming language. Now in this video, I want to highlight some of the most important things, the biggest concepts, especially ones that are going to be helpful for our future assignments. But I do want to point out that all of the details of what we're going to be talking about today are in our Java tutorial linked from our course website. You can find it here as an example, but it's also linked from a lot of other places and a lot of emails. This walks through all of the Java syntax. So in my video today, I'll be doing a more quick walkthrough of some of the most important details of the syntax here, because all of this is outlined here in our Java tutorial. So here I have an ed workspace that will be linked from the course website with this video. And I want to quickly walk through some of the things that we use in Java. So for example, if you wanted to write your simplest program, we could write a hello world. There are some things that you have to write in Java to surround your program that we'll talk a little bit more about in detail later. But we talked about this in class. We have to write public, class, and then the name of your file. In this case, it's called helloworld.java. So I'm going to say public class hello world. Then you need a curly bracket, and you have to, inside there, to make it runnable, say public static void main string bracket args. And then you have your main method where you could write all of your code that you want to run. In this case, I just want to print out hello world. So I'm going to say systemout.println hello world. Now, unfortunately, with how I have this ed lesson set up, I don't have a run button here anymore. So I have to do kind of a weird thing. Don't worry if you don't understand this. I have to use this thing called a terminal to run this. You're never going to have to use this in the class, so don't worry about it. But I'm just going to type Java and then hello world.java. And then it will tell me the output of this program. In this case, it was hello world. Okay. So again, in this video, I'm going to be using this terminal thing to run out my program just because I have a lot of files in this one lesson, or this one slide of the lesson. You don't need to worry about this command line thing. You're never going to have to use it in this class. Okay, so that's hello world. We just wrote some code. We talked a bit about the boilerplate, the stuff that goes around that you kind of need in every Java program. And all of my examples moving on from here, we're going to be just leaving that, or we already have that boilerplate already written because we want to focus on new concepts. So the next concept I want to talk about is looping in Java. So how do you do something over and over again? And in particular, I want to talk about what we might call the definite loop or the for loop, because its syntax tends to look a little bit different than some other languages like Python. The other type of loop, the while loop, does look pretty similar. You could see the syntax in the Java tutorial. But what I mean here is by definite loop is if you know exactly how many times you want something to run, there is a loop structure that lets you initialize some variables and do some counting for how many times you want it to run. So for example, if I want to write a program that, say, prints out hello 5 times, and I could just say system.out.println hello, and then copy paste that over and over again. Copy and pasting code is usually a sign that you're probably not using a language feature correctly. There might be something to abstract this away, or it built in to do something multiple times. And in most programming languages, they have this concept of loop to do this one line of code multiple times. So instead of doing this, we're going to surround this in a loop. So I'm just going to write out the loop in Java, and then I'll explain all of its parts. So I'm going to say for int I equals 1, I is less than or equal to 5, I plus plus. Start open and closing my curly brackets, and then put this line of code inside. Okay, so what did I just do? I took that line of code and put it inside a loop, so it's going to get repeated. Now, the syntax for this might look a little bit different for you in Java if you're, say, coming from Python. That the way that Python people write for loops looks a bit different with the range function, but we don't have that here in Java. Instead, you have to specify 3 parts for your loop. The first part is an initialization. So you need some variable to keep track of how many times have you looped so far. You need to start it to some value. So in this case, I'm starting at 1. The second part you need is to say when do you want it to stop? So we're going to doing this over and over again while this condition is true. So while I is less than or equal to 5, this loop will keep going. And then we need an update step. How do we update our loop variable? In this case, we say I++, which is the shorthand notation for I equals I plus 1. So what this does is it first to like walk through the steps this does. It first gets to this loop. It initializes an I variable to be 1. And then it says, okay, is 1 less than or equal to 5? Yes. So we enter the loop and we print out hello. Now that the body of the loop, the stuff inside the loop, is over, we now do an update I++, which turns I to 2. And now we ask again, is I less than or equal to 5? Yes, it is. So we print hello. And then we do our update I++, and so on and so on and so on. On the last iteration, or one of the last iterations, I is going to be 5. We ask, is I less than or equal to 5? Yes, it is. 5 is equal to 5, so it's less than or equal. We print out hello one last time. And then when we do the update step, I becomes 6. Well, I can't type 6. So now in the next iteration, we check, is I less than or equal to 5? It fails. It says nope. And then we exit a loop. So if I try running this, we'll see that it prints out hello 5 times. Okay, so that's for loops. While loops also exist in Java, but that syntax looks more similar to what you'd probably see in other languages. You could check the Java tutorial. What I want to do is I want to do a slightly more involved program that involves a class that we have not yet seen, but you might find useful for generating random numbers in Java. And I also want to review a little bit about what Java uses, what we call methods in Java. So in Java, if you want to make a random numbers, there's many ways of doing it, but one of the most common ways is to use what we call a random object. It's a thing that knows how to make random numbers. So you say random, and then you give it a variable name. So like I'm going to call it, some people like calling them Randy. I'm just going to call it rand equals new random. And then you can ask this random object to make new numbers, new random numbers. So I'm going to say random.next, and there's lots of different methods here. We usually use nextInt, and you have to give it a number. There are two ways of calling this method, one with a single number, one with 2. I usually prefer the single number version. The single number version, if you say pass in the number 9, it's going to generate a random number between 0 inclusive and 9 exclusive. So it's going to be a number 0, 1, 2, 3, 4, 5, 6, 7, or 8. Okay. You could also pass it in explicitly 2 numbers, like 2 to 9. This is saying generate random numbers between 2 inclusive and 9 exclusive. So that's 2, 3, 4, 5, 6, 7, 8. So with random, the ending point is always exclusive. You're not actually including that. So if we wanted to print this out, system.out.println, random.nextInt 2 to 9, submit. Oh, sorry. Run this. What did I call this file? Random and methods. First thing I get is I get an error saying, I don't know what random is. We actually saw one of these in class earlier. Some of the built-in Java types you have to explicitly import. So here I'm going to say import java.util.star to get everything from the Java util package. And then if I run this, it prints out a random number. If I run it again, I get a different random number. If you run it a bunch of times, you'll get different random numbers each time. But note, we got 2 6s in a row. That's totally expected. You could flip a coin and it turns up heads twice. It's completely random, or in this case, Java calls it pseudo-random. Okay, so what I want to do is I want to extend this a little bit, where I want to write some code to say, generate a few random numbers, and then maybe calculate their sum or something like that. So here, what I could do is I use that definite loop. So say I know I want to do 5 numbers, generate 5 numbers. So I could do is I could say something like for int I equals 1, I is less than or equal to 5, whoops, I plus plus, and then say generate a random number here. And let's change the bounds here. Let's generate a number between 0 inclusive and 10 exclusive. So this is a 1 digit 0 to 9. If I try running this, it will print out 5 random numbers. So we see 6, 4, 9, 4, 5. Great. But I wanted to compute their sum. So what's the total of these numbers? Now, I'm just printing it out right away, but I could say, save this in the variable, int number equals this. And one of the patterns we see a lot in Java is this one that we call a cumulative sum. So if you're like adding something up in a loop, How it usually works is you have to start off a variable before your loop, saying something like sum equals 0. So it's some starter value. And then inside your loop, you're going to be updating it in some way. So in this case, I'm going to take the sum and add on the number. Now you could write it out like this, sum equals sum plus number. But it turns out Java also has a shorthand syntax because updating a variable like this is so common. You could say plus equals. With plus equals, it just takes the number, adds it to sum, and then stores it in sum. At the very end, you can print out println the sum is equal to sum. If I try running this now, it says the sum is 26. Then the sum is 6. Maybe I got unlucky and rolled low dice or something that roll or that time. Then I got 23 and so on and so on. So that's random in Java. This won't come up a ton, but we will sometimes use it. But this idea of cumulative sum is an important part for this example. Now what I want to highlight, though, is another useful feature in Java, which is what if you wanted to do this multiple times? What if I wanted to say calculate the sum of 5 random numbers generated, and then say calculate the sum of 10 random numbers generated, or something else? Your first instinct might be, oh, okay, maybe I can copy some code. But you're not, well, as I mentioned, while you can do that, it's not the best in terms of code quality. You usually want to make sure that you only have to write something once and reuse it as much as possible. So that you don't have to say, for example, if you wanted to change how it's printed, that you don't have to update that in a bunch of places. So what we're going to do is we're going to introduce, instead of copy and pasting this and doing it in multiple places, instead what we're going to do is add a method. So I'm going to say public static, this case, maybe I'll just make it a void method. It's not going to return anything. And I'm going to say, call it generate random sum. And then I'm just going to take all this code and move it here. Generate this random sum. Now the hope is in this main method, I can now just call this function. I can just say generate random sum. So this is making like your own new type of method. You're saying that I want to make a subroutine, is what they're also called, that does this thing every time I call it. Now, a couple things about this are going to break. So the first example, if I try running this, it says, hey, I don't know what rand is. And Java gives you helpful error messages, and it tells you exactly which line is not working. It's saying it's line 13. And it says, I don't have a variable called rand. So one thing that's really important for Java is this concept of scope. Where does a variable live? And in general, the scope of a variable is within the closest set of curly brackets that defined it. So what I mean by that is that like in this rand variable lives in the main method. It's part of main's scope. It doesn't live in any other method. So here, because this generate random sum is a different method with its own scope, we don't have that random variable here. Now, one easy fix to this is just move this one line down. You could totally do that. Whoops, I didn't. Now this random variable is defined inside the scope for this method, and it's totally fine. That would be one good solution to this. I want to show you another one. Sometimes it makes sense to do this where you might want to only have one random object and use it a bunch of times. The other idea is to pass that data into your method using a parameter. So what you could say is give the random variable to your method. Now, this won't compile if you just run it like this. It says, hey, you tried calling generate random, passing something in, but it doesn't want anything. You have to define what parameters it takes. So in this case, to make it match, I'm going to say it takes a random variable, and we'll just also call it rand. But note that this is a completely different variable. It has a different scope. You can call it something else if you wanted to, and it has changing it rand does not necessarily change anything in main. Also, if you want to, so if I run this now, this now says the sum is 28. Now, parameters are really useful because it lets us parameterize our methods, meaning that you can make them do slightly different things based on what parameters they get. So for example, if I wanted to change the number of random numbers that are generated, I could make that into another parameter. I could say int num to generate, and then use that number here instead of 5. Now, when this when we call it, we also have to specify, okay, how many you want to generate. So how you call always has to match how you define the method header. So in this case, if I want to generate 5 numbers, I could do that. If I run this, it will generate those 5 numbers like before. But very nice is that you could do this again. Generate random sum, and maybe I want to generate 10 numbers now. It will now call this method again, doing all that stuff, but now with 10 numbers instead. Finally, with methods, if you want to return something, you could use the return keyword to return the sum. But you also have to make your method header match that. So you have to say it returns something of type int. And very commonly, anytime you have a method that returns something, you probably want to catch its return into a variable. So I'm saying, okay, take the value that generates sum's returns and stores it in a variable called sum in the main scope this time. Okay, so that was a lot about methods and parameters of returns. Just note that that concept of scope is going to be really important for when you're writing code. So if you ever get this like variable not defined, that's probably an issue of where you defined it in its scope. Okay, so for our last couple of problems, I want to focus a little bit on 2 remaining concepts. The first being how to do user input and with files, so both of those using the scanner class. And then finally, I want to do a little bit with arrays. Okay, so we saw a little bit in class about this, so I'm going to go over this slightly quickly, but I wanted to have this in this video just for completion. So when you want to gather user input from a program, we mentioned that you used the from the java.util package, you use the scanner class. So I'm going to say scanner input equals new scanner. And if you want to get something from the user, we attach this scanner to system.in. Now what this lets us do is this lets us prompt the user for a particular thing. So for example, I can ask system.out.print, what is your name? And then ask the user input.next. And I will save this into a variable called name, and then print out println hi plus your name. Okay. So now when I run this, I'm going to say Java user input. Import java.util star. I forgot a dot right there. What is your name? My name is Hunter. And that says hi, Hunter. So every time with the scanner you ask for .next, it pauses the program. Let me run that again just to make that really clear. The program is paused right now on this line, waiting for me to type something in. So in this case, I'm going to type in Hunter, or I'll type in Mia this time. And then once I hit enter, it continues on and then has that value stored in a variable. Now, scanners are very nice because you could do lots of different things with them. Like you could ask for someone's age. So I could say system.out.print, what is your age? Now, when you ask the scanner for something, you could ask it for a next. That would the user type in something and return it. But one thing that scanners do really well, and the reason we use them, is they're really good at converting between types when a user types something in. So for example, if you know the user is going to type in something like an integer, like a number 28, then you can ask for the next int. And then it will return this as a variable or as a value of type int. Now, let me just print out what this says, system.out.println. Your age is age. Okay, let's try running this. Java user input. What's your name? Hunter. Hi, Hunter. What is your age? 27. And it says your age is 27. Now, this is really nice because the user just types in whatever they were going to type in. But now in your program, you have it as a value of type int rather than trying to figure out how to convert a string to an int or a string to a double or something like that. So scanners are really nice, but you have to be careful because user has to type in valid input. For example, if I tried running this again and I said, what is your name, Hunter, and what is your age, Mia, the program crashes because it tried to convert the word Mia into a number, and Mia's name is not a number, so it just crashes. So there's one common type of error you might run into with user input is making sure they type in the right thing. And crashing is okay. And many times in our class, we say just assume the user will type in valid input because handling these errors is kind of tricky. Okay, so that's user input, but I will continue our discussion of scanners here where we mentioned also this in class, that scanners are useful for getting data from lots of different sources, including from files. So not just user input, but it also works well from files. So I have this other file here called file practice. Also note, should have mentioned this at the beginning of the video, but all of this stuff is going to be in this ed workspace so that you have access to all the things I typed, so you don't have to be frantically typing this down. So here's what I want to do for file practice. I have this file here called poem, she sells seashells by the seashore. And what I want us to do is I want us to read this file and do some analysis on the number of the number of characters that appear on each line. But before that, let's just do some practice reading from this file. So like I mentioned before, if we want to read from a file, we have to import java.util.star, and I have an extra dot there, so I will fix that. Java.util.star. And I can make a scanner. Maybe I'll call it file input equals new scanner. Now, instead of attaching it to system.in, what I want to do is attach it to a file. In this case, I want to attach it to poem.txt. So I have to make a new file object to say attach it to a file called poem.txt. And then it will be set up there. So every time you prompt for next int, whatever, it's pulling from that file. Now, there's a couple problems with this, with how I just written this. If I tried running this, it will not work. So if I try running file practice, it says, I don't know what file is. So that's one error. Turns out that file lives in a different package than java.util. It lives in java.io.star. But fixing this does not actually fix our program, because it says, whoops, I did not save. New file. Oh, that's weird. Oh, jav.io.star. There we go. Now it's still not fixed. I did not fix it. Okay, there we go. One last time. Third time's the charm. Okay, so I fixed the error. It now knows what file is, but it's still not working. It's saying, hey, file not found exception must be caught or declared to be thrown. This is a weird quirk of Java. There are certain types of errors they're really scared about. In this example, they're really scared about you trying to read a file that doesn't exist. And so you have to do a little bit of extra work to tell Java, hey, I know that this might happen and I'm okay with the consequences. There's no actual consequences here, but Java makes you type this out. What you have to do is you have to change your main method to acknowledge the fact that this file might not exist. So you have to say throws file not found exception. This is just telling Java, hey, I recognize this type of error might occur. And so you're putting this here to let Java know that you know what's up. Now, if you run this, it will run fine. It doesn't do anything because we just made a scanner. We didn't actually read anything from it. But this is some kind of common boilerplate that we need for file processing, as this throws file not found exception. Now, let me just go through and read every word inside this scanner. So a common pattern with scanners is to say something like, while file input has next, system.out.println, file input.next. If I run this now, it'll print out all of the words of the file one by one. Okay, all the words of the file. This is a very common pattern. While you say while has next, do next. There are lots of similar patterns here. Very commonly, as we mentioned, there's like next int. There's also lots of other types of next methods. It's really important usually that you have the has next match whatever the next call you're calling it. So for example, if I was asking for a bunch of ints in this file, if I were reading next int inside, this would break because there actually are no integers in this file. But if I were doing that, you'd also want to make sure that your has next call matches that. So you'd be using the has next int method. So again, I'm not actually going to be using ints in this example, but I just wanted to point out if you were asking for a different type of data, your while loop should also be saying while there's that type of data in there. Now you can do lots of other things with files. For example, if you wanted to print out everything on a single line. So what we just did was what we called token processing. But sometimes you want to go through a file line by line and actually treat something about its line. So in that case, instead of asking for the next token, the next word, it's very common where you ask for has next line and ask for the next line. In this case, if you run this again, it's going to have similar behavior, but each call to next line returns the whole line of output. So it returns C shell or she sells, and then seashells, and then by the sea, and then shore. And you can do whatever you want with this. This is just a string. If I wanted to say string line equals file input dot next line, I could print out that line. No, but you could do lots of other things if you want to make the line uppercase, or a very common thing is you might want to actually go through that line and do something with all the words on that line. So maybe counting the number of words on that line. So one way of doing this in Java, it's very convenient, is you can actually use another scanner to break apart a single line of text. So what you could do is you could say something like scanner line scan equals new scanner, and pass in just that one line of input, or that one line from a file. Now with this line scan, you could do a single line of processing. So do something like while line scan dot has next string word equals line scan dot next. And if you wanted, you could print it out. System.out.println word. Now we get back to that first version of the program we had essentially. In this version I have right now, I'm looping line by line and then breaking up each line into word by word and just printing them out. That's equivalent to just processing the whole file by words. Now, however, this approach I just wrote down is much more flexible than that though. For example, what I could do is compute, say, the number of words on each line. What I could do here is I could say int num words equals 0. Instead of printing it out, I could say num words plus plus. Then system.out.println there were plus num words. There were 2 words, there were 2 words, there were 3 words, there were 1 word. So 2, 2, 3, 1. So this kind of general approach lets you do lots of flexibility, where that first approach I showed you of just calling next all the time loses the structure of the lines and just returns all of the tokens word by word. So this is the more general pattern of going line by line and then breaking up that line in a particular way that you see fit. Okay, in our last few minutes, what I want to do is I want to talk about our last core course concept, which is arrays. So using a sequence of data. The syntax for arrays in Java can be a little weird at sometimes, but we work with it, and we'll see some of the data structures we get to later in CSE 122 actually make the syntax a little bit nicer in a way, or a little bit more consistent. If you want to make an array of numbers, say in this case integers, instead of having a variable called int nums, you want to say it's an array of them. You use int bracket bracket to say I want an array of numbers. And if you want to make a new array, you say new and then int array. But one thing you have to specify is how many numbers you want in there, how much space is then in that array. So I'm going to say int bracket bracket nums equals new int array of 5. What this does is it makes a list of boxes 5 long, and there's a box for 1 int inside each of them. Okay? So it's making a consecutive chunk of memory to write down 5 numbers. To start with ints, the array values become 0. So arrays always default to the 0 equivalent of whatever type you're working with. So ints at 0, booleans, that's false, doubles at 0.0, and so on. But this is making 5 spaces. Now, if you want to, you could print out what is nums. Println nums. Unfortunately, in Java, the printing arrays does not look that great. It prints out all of this garbage up to the screen. It turns out to get Java to print arrays, you have to use a special method call called arrays.toString. And that is actually, that's a method that the people at Java wrote to take an array and make it a nice, pretty string output. Now, one thing we'll find if this types, oh no, I think my ed workspace froze. Okay, let's refresh the page. Arrays practice. Java arrays practice. It says, I don't know what arrays is. Yet again, it's something that lives in java.util.star. Now, if I run this, we get an array of 5 zeros. If you want to access something in that array, you could say nums of 2 equals 3. What this is saying is changing the value at index 2 to the number 3. If I try running this now, you'll see that this value here got changed to number 3. One thing to note about arrays in Java is there's 0 indexed, meaning the first thing is index 0, then index 1, then index 2, 3, and 4. So an array of length 5, the valid indices are 0, 1, 2, 3, 4. So you could do assignment here. If you want to print out a particular number, you can access using the same notation, nums of 0. This gets the thing at index 0. If I try running this, it'll just print out another 0. And the last thing I want to show you about arrays is our common traversal pattern, which is if you want to loop over all the elements in an array, say getting their sum or something like that, a very common pattern for this is to use a for loop. And you say, and you have your index I, or your loop variable I, go over all the valid indices. So the start index is 0. That's the first valid index. So it's very common with array code to have your loop start at 0. You want it to go until the end of the array. So to ask the array how long it is, there's a method called length. But it's not, sorry, I should misspoke. It's not a method. You don't put parentheses here. It's what we might call a property or a field. We'll get that terminology later in the quarter, so don't worry about that yet. Just know if you want to get the length of an array, you say nums.length. Now, importantly, here I wrote less than and not less than or equal to, because we don't want to go to the length of the array. Note, for an array of length 5, the valid indices are 0, 1, 2, 3, and 4. So it stops at 4. So we don't want to go up to and including the length of the array 5. We want to stop before that. So one way of doing this is say, okay, well, it's less than nums.length, or you could also say less than or equal to nums.length minus 1. But this is a very common way of writing this. I++, and then doing something like system.out.println nums of I. It's a very, very common pattern of writing a for loop to traverse over everything in an array. Okay, so that's all of the core Java features I wanted to review. Note, again, this didn't go through every single detail. The Java tutorial's there, but hopefully this gives you enough of the common gotchas and helpful tips to think about tackling some of these practice problems on this handout and some of the problems on the first assignment.